6, we're going to learn about the engine and its associated systems. So we're going to start with mostly the four-stroke engine cycle, carburetors, like how fuel is delivered to the engine, and the ignition system. And then there'll be two other parts to lesson 6. One's about like fuel systems. Another one I think is about oil and propellers and electrical systems. But those are all engine associated systems. And so we're going to start with this one right here. So get your notes ready. There is a packet for this one. Make sure you have those notes ready to go. We're going to do the first part, 6.1 of lesson 6. And this has to do with the aircraft part of the private pilot knowledge. We're going to do some airframe stuff in class. And now we would jump to the engines. Remember, there's intake, compression, ignition, and exhaust. And you need to know those 4 things and what they do. So hopefully you covered that in class. Right here, there's ignition, compression, ignition, and exhaust. And this is what it looks like inside the cylinder. And this thing that's turning down here, this is called the crankshaft. And all the cylinders are attached to that crankshaft. And that's what, in a lot of planes, the propeller is actually mounted directly to the crankshaft. So as this is turning, and this is going very slow because in normal flight, the crankshaft's going about 2,500 RPMs. And so, that's revolutions per minute. And so, that's pretty slow right there. And where does the fuel come from? On the first stroke, it says, on that one's called intake, and the definition is it intakes fuel and air mixed together into the cylinder. Where does it come from? Well, it comes from sometimes this thing called a carburetor, or it comes from some sort of fuel delivery system like fuel injection or something like that. Most airplanes have 2 controls. One is a throttle and one is a mixture. If you ever see a blue knob in between those two, that is that's usually a propeller control. So we're going to talk about these 2 knobs, and we're going to talk a lot about this thing down here called the carburetor today. And this is the mixture handle, the red one with little ridges on it, and it's going to control how we mix fuel and air together. And we're going to talk about that a little bit. And then that's the throttle. That's what's being delivered to the engine. So basically, the mixture is controlling this little needle here that's mixing the fuel and air together, and then the throttle is opening and closing this gate here, which is allowing air and fuel to be delivered directly to the engines. So this is a diagram of a carburetor. So if there's a picture of that in your notes, you may want to label these parts and pause it here. All right, so here's how it works. Fuel is pushed into the carburetor from the fuel pump. Okay, so it's being pulled from the fuel tanks by this thing called a fuel pump. The mixture needle controls the fuel to the discharge nozzle. So if you're wondering what the discharge nozzle is, it's this thing right here. This is the discharge nozzle. It's down here at the bottom of that figure there. And then where it is mixed with air from the air inlet, and this creates the fuel-air mixture, which is then sent to the engine by the throttle. So make sure you have all those filled in. While people are filling that in, I'll just explain something. As you go up in the atmosphere, the air gets thinner, so you need less fuel. We call that leaning the mixture because there's less fuel to be mixed with the air. There's a really nice ratio of fuel to air that we want to maintain throughout flight. And if it's got too much fuel for the amount of air available due to the density of the air, then it's called rich. The mixture is too rich. If it's too little fuel, it's too lean. And there's good and bad things about both, and we'll talk about those in a little bit. There is something with carburetors. There's a little problem with carburetors called carburetor ice, and it's not caused by flying through a cold cloud or anything, because usually temperatures around 70 degrees Fahrenheit or 21 degrees Celsius are typically the most they're the biggest culprits for carb ice, and you have a high humidity around 80%. We're going to talk a lot about that in class. But if you are flying along and you have some indications of carb ice, here's 4 things you need to write down. You'll get some engine roughness, you'll get loss of RPM, you'll get engine stoppage, and most likely it's occurred during low power settings, and we'll talk about that in class as well. Here's a little video about it, and what carb heat is. And what's the third stroke in the 4th cycle called? Remember what that's called? It's called what? It's called ignition. There, you see a little spark right there for ignition. That's ignition. And so where does that spark come from? And you might say, I think it comes from this thing right here called a spark plug. That is true. But what causes it to spark? Well, let's talk about spark plugs and magnetos. So essentially you have your 4 cylinders. Most of them have 2 spark plugs, one on the top and one on the bottom. So you've got your cylinder there, and you've got one on the top and one on the bottom, and there's a wire going to each one. And that way, if well, I'll explain in a minute, but each one has two. So there's really, in a 4-cylinder airplane, there's 8 spark plugs, one on the top, one on the bottom, that helps it burn smoothly and evenly. Now, one of those spark plugs to each one, follow those green lines on your screen there, and you'll see that each one has, a spark plug line going to it. The magneto, there's 4 for the left and 4 for the right magneto, and those are really just spinning electromagnets inside of a coil that's sending out sparks. They are engine driven. They're not part of the electrical system. They're their own thing. As long as the engine crankshaft is turning, the magnetos are turning and producing sparks to the engine. So it's kind of a cycle. We'll talk more about that in class. But you have a left and a right one. The reason why is because that way you have redundancy. If you lose your left magneto, you still have the right magneto giving sparks to the engine. Now you will lose a little bit of RPM, but you'll still have enough RPM to get somewhere. You only lose about 100, 150 RPM if you lose a magneto. Also, down here in the bottom left corner, you'll see a little picture here. This is a typical switch. You have off, that means that there's no ignition. R for right magneto only. Left for left magneto only. B for both magnetos. And then you have a starter. We're going to talk more about that in class as well. All right, so here's how it works. The engine has a self-contained power it can supply to the engine's spark plugs. It spins magnets called, and you should know this by now because we just talked about them, they're called magnetos, to create electricity. And then this electricity is sent to the spark plugs to ignite the fuel air mixture. So fill all that in, please. Now you can get a case of what we call abnormal combustion. We do this sometimes with the textbook in class. I'm just going to go ahead and give it to you right now. Number 1, pre-ignition. This is when things happen. It gets ignited in advance of normal ignition and is caused by a hot spot in the cylinder. There's also something called detonation. This is uncontrolled explosiveness in the explosion, it should say, in the engine chamber. It should say explosion. I don't know why that happened there. I'm going to change that really quickly. So that's fixed. It's caused by overheating and using too low of a fuel grade. We're going to watch a video about that in class as well. I will say this really quickly, just kind of in case you're wondering, sitting there wondering. This one's detonation's caused by too lean of a mixture. Lean is mean. Engines run hot when they're too lean. And this one's called by too rich. If it's too rich, it means it has too much fuel for the fuel air mixture and it doesn't burn as cleanly, and therefore it usually leaves a little bit of charcoal or a little bit of carbon inside the cylinder, and it ignites before the spark plug ignites if it gets like a little hot, like coal in there, and it just ignites. So this one's too rich, this one's too lean. We'll talk more about that in class, of course, as well. All right, that's the end of part 1 of your notes. That's the end of part 1. For the next part, you'll need the section of notes for lesson 6.2.